math for real people. So what we're going to continue on doing is Algebra 1, Chapter 1, and we are on Lesson 3. And you can see it says we're going to work on properties of real numbers and putting them on a number line. Sounds simple enough. What we're going to do is go through a bunch of definitions, and then we're going to make sure we can put things in order if it's represented as a fraction or decimal, where it would go. Okay? So let's go ahead and get started. So first, here are the definitions, and I'm just going to say them. And the thing I want you to do before I say anything is take a look at this diagram and do not overthink when I explain it. Don't look at it and be scared right now, because there's no reason to be afraid of words and numbers. For real, there's not. So looking at the inside, this is called natural numbers. So knowing the names of numbers will help you, especially if you're in Algebra 1 or wanting to learn it, because they're going to keep saying stuff. Natural numbers, you can think of them as things found in nature. They start with 1 and go up, because when you look at something outside, you start counting with 1. It does not include 0 because 0 is included in the whole numbers. So all natural numbers are whole numbers. Whole numbers include all natural numbers and 0. That's the only difference between a natural number and a whole number. All integers include all whole numbers. Integers are all positive and negative whole numbers. So the integer added the negative part. Then we move out to rational numbers. And a rational number can be written as a ratio or a fraction. So if you see something that's a fraction, it's a rational number. Now, obviously, these can be written as decimals, and it can be positive or negative. But if you see a decimal, you can still figure out if it's a rational number. If it ends, like 0.5, it's done. 0.12, it's done. It's rational. If it goes on forever, like 2/3 is going to end up being 0.6 repeating, that's rational because it has a pattern. So even if something goes on forever, a decimal goes on forever, so the 1, 2 repeats, it has a pattern, it's rational. When you look over here at irrational, that's where you no longer can use fractions. They're irrational. They cannot be put in a ratio. If you see it as a decimal, it will go on forever, and it will never have a pattern, just like pi. Goes on forever, no pattern. A lot of square roots go on forever, no pattern. So you'll notice that all of these things are real numbers. So irrational, they're over there by themselves. Everything else you can see fits inside of a rational number. And that's how the little diagram works to help you understand it better. Imaginary numbers are way over here. I realize that they're called imaginary. It's silly, but you'll learn those later. So we're not going to talk about them now. Just know that they're there. There's real and then there's imaginary. And we're going to talk more about real numbers. And we're going to put some real numbers in order. I'll give you one example. And we'll talk about whether it's rational, integer, whole number, natural, and so on. Okay? Okay, so here's our numbers. And we need to look at these and be able to tell what they are based on our definitions from the last little clip there. And we need to be able to put them on a number line. So let's remember, with a number line, we have our negative numbers over here. And then there'll be 0 and then positive over here. So just don't forget that. First thing we'll do is look at one number at a time and make sure that we can compare it to another number. So -1, that's not a decimal or a fraction, so we don't have to worry about changing anything. -1, if we look at our circle with all of our definitions here, -1 cannot be natural. It's not a whole number. It would fit into an integer. So it's an integer, which means it's rational and a real number. So you can say all of them, or you can say the one that it is first, depending, of course, on what you are assigned to do. So that was an integer. Now, if they give you something like the square root of 4, the square root means what times itself equals 4. So that's really a 2, right? The square root of 4 is really a 2. So we can think of it as a natural number, whole number, integer. It's all of those things. It's a natural number. And then we can look at the negative 0.5. Now it's negative, so you can think, oh, we can start by just looking at the integers, but an integer is a whole number. So that kicks it out to be a rational number. So negative 0.5 would be a rational number. And then 3, another whole number there. So natural number. So now let's put them in order. Well, we only have one negative, so let's go ahead and put it to the left of our 0. And I'm just going to put on my number line the numbers I'm given. I don't need to add anything different here to look at. And I always cross it off when I'm done. Oops, that wasn't the most negative, was it? Just kidding. There's your negative 1, negative 0.5. The more negative you get, the more to the left you go. And then the square root of 4, which is 2, would be on the other side of the 0. So you leave it as the square root of 4, even though it does make a 2 for an answer, you want to leave it as they give it to you. And then there is your 3. So let's look at one more to put in order. Okay, so here's another example. So what I want you to do is pause it, see if you can label all of these numbers, and put them in order. So pause, and you should be back. So I'm going to go over these quickly. Pi is irrational. It cannot be written as a ratio. It goes on forever without any pattern. It's an irrational number. Negative 4, you should have gotten it's an integer. It's a negative whole number. 0.35, well, that can be represented as a fraction. It's a decimal that ends. So it is a rational number. And then 3/4, well, it is a ratio. It's written just like that for you. And as a decimal, it's 0.75, right? Everybody knows 3/4 is 0.75. So that would be a rational number. And of course, all of these fit into our real numbers that we're talking about. So let's quickly put them on the number line. So my negative for real this time, my most negative one, is negative 4. So that goes furthest to the left. Then the thing closest to 0, well, pi is 3.14. Now I have everything represented with decimals instead of any fractions. So that's helpful. Thing closest to 0 would be 0.35. The next smallest one would be our 3/4. Remember, it is 0.75, but we write down what they gave us. And then 3.14 is pi, and that is your order. So that was math for real people. Don't forget to check out the rest of the blog and more videos to come. Thank you.